In previous video, we have learned about some predicate functions, user-defined functions, like making use of defined construct to define some functions. And also, we have learned about some binding constructs using let star, and let rec. So in this video, we will be learning about some control flow statements, control flow constructs, and the functions, list functions, what all are being used, how it can be implemented. Those things we will be learning in this video. So starting with the control flow constructs, here we are having two different constructs like two-way selector and multi-way selector. So two-way selector, it makes use of the if constructor. If will be used, and as if statement has three parameters like a predicate expression, then expression, and an else expression. So if construct, if construct is used, it means that it is a two-way selector. It will be having a predicate, that is the condition. Then if that condition is true, then then expression, that is yes, and followed with an else expression, that is here in this case it is no. So if 5 greater than 2, so this predicate will be in the form of prefix format, like operator will be coming to the left hand, then the left hand side operand, and the right hand side operand, greater than 5 2, so which implies 5 greater than 2. If it is true, then it returns yes, or else it will be returning no. So in this case it will be returning yes. Similarly, in this case, instead of this statement, you will be having an expression like it will be evaluating 5 plus 2 if 5 is greater than 2, and hence it will be returning the result as 7. This is the case with two-way selector. And in case of multiple selector, it is based on mathematical condition expression, and in order to implement this, it makes use of a form called as COND. So syntax is COND followed by predicate 1 expression, predicate 2 expression, predicate like that, predicate n expression. It is like you implemented nested else if statement in C language. Similarly, we make use of this COND construct in order to implement this multiple selector. If these expressions, all these expressions, if they return false, then it will be moving to an else category, which will be executing some other expression. So predicate of the parameters are evaluated one at a time from first until it reaches to the result true. If none of the predicates are true, then there is an else, and this else, it will be evaluating an expression and the value will be returned. So when this else will be returned, if none of the predicates, they are returning the value as true. If they didn't return the value as true, then it will be moving to the else part. Multiple select example you can give like this, in which make use of define to define some function compare, taking two arguments x and y. So in that x will be checking for some condition. So multi-way selector, it will be using the construct COND. If the condition is true, it will be displaying one statement. If condition, this less than condition, if it is true, then it will be telling that y is greater than x. Else, it will be telling both are equal. So if values are given, 5 greater than 2 means it will be displaying greater. 5 less than 2, it is false. And this, so since here it returns a value as true and displays this result greater, it won't be moving to the next these statements. So this is the case with multiple selector using COND, two-way selector using if. Then coming to the list function, CAR takes a list parameter in which it returns the first element of the list. So as discussed earlier, the list will be in this presented in this format, that is within bracket you will be mentioning the elements that belongs to the list, and a quote symbol, this symbol will also be used. So this is a way of representing a list. So CAR, this list representation, if it is given, means it will be yielding the value as A. Why? Because CAR, it will be returning the first element A from the given list. So next one example, CAR, this is the list. Okay, in this case, AB is one element, C and D is another element. So in this case, CAR means this AB will be returned as the first element of the list. The next CDR, it takes a list parameter. So in the CDR, list is taken as a parameter. What it returns? It returns a list after removing its first element. So it will be returning list after removing the first element. So the result is BC, it is BC. So in this case, what happens? It will be removing the first element, yields the result as CD. Then comes CONS, in which it constructs the list. In this also, it will be taking the parameters in the form of list only. That is, it will be taking two parameters. The first one can be either an atom or a list. Followed, second parameter will be like, it will be a list. Okay, first one can be an atom, that is a single element, or a list it can take as a first parameter. Second one will be always a list. If this construct is used, then it will be returning the result as a single list in which first parameter and second parameter, they are combined to form a single list. So it will be returning a new list which includes the first parameter as the first element and the second parameter as the remainder of its list. Then the three basic list operations here are head of the list, that is CAR, CDR and CONS, in which CAR, head of the list, it returns. CDR, removing the head, the rest of the list will be returned. CONS, it joins the head to the rest of the list. Then using lambda expressions, how it can be implemented. So lambda of L is a list, and it calls for the state that is inside the body, it will be given as CAR of CAR L. L is called as the bound variable. That is a list that is given. So in this case, value given that will be processed is a list having AB as a first element, C and D as second and third one. So it will be given as a parameter to this lambda expression, in which first what it does, CAR of this list it will be doing. So CAR means it will be taking the first element of the list, that is A and B. Again it does the CAR operation, in which from this A, B, what is the first element? A. Hence A is returned as the result. Then how expressions they are evaluated in this scheme. So it makes use of read, eval, print loop, or read, eval, write loop. So scheme expressions, they are also called S expression or symbolic expression. They are either list or atoms. So these expressions, they can be either a list or atoms. The parenthesized string of symbols will be called as the S expression, regardless of whether we think of it as program or a list. Unevaluated program is a list and can be constructed or deconstructed and otherwise manipulated with all the usual list functions. So unevaluated program is a list which can be constructed or deconstructed with using this normal list functions. Lisp and scheme, they are homo-iconic, which means that they are self-representing. So this Lisp and scheme, they are different languages. Lisp, list processing languages. Then here we make use of two functions, that is eval and apply functions. So we need to know the features of this eval and apply function, how it is being executed and how what is the order of execution, these we need to know. So scheme provides an eval function that can be used to evaluate a list that has been created as a data structure. So in this example, define compose, it will be taking define. From this define, you will be able to know that this is a function. Compose is a function. It will be taking two arguments. Using the lambda expression, it will be taking two arguments, that is two functions f and g. So what is the result it will be giving? It will be taking one parameter. Again, this lambda function, it will be taking one parameter x, which will be a list. Okay, so g function, which will be first applied on this x, you will be getting one result, and after that, to that result f will be applied. This is the way the function is defined here. So when this function is being invoked using this statement, compose CAR CDR, so CAR will be f and CDR will be g. 1, 2, 3, it will be the list given as a parameter x. So first g will be applied to x, you will be getting the result as CDR means it will be removing the first element. So you will be getting the result as 2 and 3. Again, applying CAR on that result, result is 2, 3. From that, if we apply CAR, you will be getting the result as 2. Then scheme provides an eval function that can be used to evaluate a list and that has been created as a data structure. So here a normal function it is being given, in which evaluation and everything will be done in the lambda expression. So in the scheme, eval function will be used, which will be having what this eval function will be having. It will be having a list as parameters which is not evaluated. Okay, so it will be taking the list as parameters, and using this eval function, the evaluation will be done. Here it makes use of one environment, scheme report environment file, which means that eval function says in which version of a scheme this evaluation need to be done. Okay. Then features of eval function, eval and apply, they are mutually recursive. When passed a number or a string, eval, it simply returns the number or the string as such. When a symbol is being passed, it looks at that symbol up in the specified environment, in which version it belongs to, it checks and returns the value to which it is bound. Okay, it will be checking for the environment and then it returns the corresponding value. When a list is passed, when passed a list, it checks to see whether the first element of the list is one of small number of symbols that name so called the primitive special forms. So whether the first element of the list, it belongs to the primitive forms, primitive functions using the lambda or define, like that, some functions, whether it is being used. In such a case, what it does, it provides the direct implementation. So if primitive function is used, it does the direct implementation if list is given as a parameter. For other forms of list, where such primitive functions is not used, what it does, it eval calls recursively on each element and then calls apply function, passing as arguments the value of the first element, which will be a function, and the list of values of the remaining elements. So this process will be done when a list is passed as an argument, and it's the first, when a list is being passed and the first argument, it doesn't belong to the primitive function. In such cases, eval, it will be calling the apply function. Finally, what is the result that is being applied function? It will be returning to the eval. That will be the final result given for display. Applied, it takes two arguments, that is a function and a list. It achieves the effect of calling the function with the elements of the list as arguments. Features of apply function. When passed a function f and list of arguments L, apply inspects the internal